Hey, welcome back. It's Mr. Geist, the Science Geek. We're going to get started with Chapter 2 today, and we're going to talk about a few things. The first thing that we're going to talk about is how to understand the components of an atom. Next, we'll try to figure out how many protons, electrons, and neutrons an element has. And the third thing is we're going to differentiate between an isotope and a regular element using the periodic table. Atom comes from the Greek word atomos, which means unable to be cut. When you look at an atom is the smallest part of that element that still has all the properties of that element. There are three parts to an atom: the protons, the electrons, and the neutrons. The Greek philosopher Democritus thought about what the smallest piece of matter might be. He took a piece of paper, he ripped it in half, and he kept ripping it in half over and over and over again until he could no longer rip that piece of paper in half, and he called that an atom. An atom consists of three subatomic particles: the proton, which is positively charged, and the neutron, which is neutrally charged, in the nucleus of an atom, as well as the electron, which is negatively charged and surrounds the atom's nucleus. Since we took a look at the charges of each of the proton, electron, and neutron, let's take a look at their size. The proton and the neutron are both very similar in size, even though that they are really small. Now, electrons, on the other hand, are extremely small. So later on, when we start to look at the mass or the weight of an atom, we want to keep in mind that most of the atom's mass comes from the proton and neutrons, and a very small, insignificant amount of mass comes from the electron. In class, I'll be giving you a periodic table of elements chart. This is going to help us out in our studies for Chapter 2, Section 1. We will use this periodic table for many problems in this chapter, so please keep a hold of it and make sure that you take good notes, as you will be able to use the periodic table for your homeworks and for your quizzes. Two things I would like to go over in this tutorial are groups and periods. Groups on the periodic table go north to south, and periods go east to west. So if I asked you to give me the element that is in group 18, period 1, you'd be able to come across to group 18 and down to period 1 and tell me that it is helium. On the next slide, we're going to take a look at the numbers that surround helium, and I'm going to tell you what those numbers mean. Now that we've taken a look at the periodic table, let's hone in on helium. There's a lot of information that is portrayed on the periodic table. So let's take a look at helium right here, and we'll decipher what these numbers mean. First off, let's take a look at the symbol. The symbol is He. For all atoms with two-letter symbols, the same rules will always apply. The first letter will always be capitalized, the second letter will always be lowercase. The other pieces of information that can be found by looking at helium on a periodic table are the atomic number, which gives us the number of protons and electrons in that atom or element, and the atomic mass number. The atomic mass number tells us the total mass of an atom. That includes protons, electrons, and neutrons. So if we only want to figure out how many neutrons are in an atom of helium, what we have to do is we have to take the atomic mass and subtract the atomic number from it. So if I gave you this problem, you should be able to tell me that the number of protons and the number of electrons equal 2, because it's the same as the atomic number. The number of neutrons equal the atomic mass, which is 4. We always round to the nearest whole number, so the atomic mass is 4, and we subtract the atomic number 2 to give us 2 neutrons. So in an atom of helium we have 2 protons, 2 electrons, and 2 neutrons. So a lot of you will probably begin to wonder what the difference between an atom and an element is. Throughout this presentation I have been using atoms and elements pretty much interchangeably. An element is a pure substance that consists entirely of one atom. Atoms are the smallest portion of that element that possesses all the properties of that element. Remember, an atom cannot be cut. Elements can be cut down into atoms, but an atom cannot be cut. Let's go over some examples of how to figure out how many protons, electrons, and neutrons there are in an element. First, let's take a look at fluorine. The atomic number is 9, and the atomic mass is 19. Using this information, we could figure out how many protons, electrons, and neutrons there are in an atom of fluorine. Remember that the number of protons and the number of electrons are equivalent to the atomic number, which is 9. The number of neutrons in an atom is the atomic mass minus the atomic number. So 19 is the atomic mass, 9 is the atomic number, which gives us 10 neutrons. Now we're going to take a look at oxygen. We're still going to figure out the number of protons, electrons, and neutrons there are in an atom of oxygen. For the number of protons and electrons, it's just the atomic number, which is 8. The atomic mass, which is rounded up to be 16, subtracted by the atomic number, which is 8, will give us the number of neutrons, which is also 8. There are 8 protons, 8 electrons, and 8 neutrons in an atom of oxygen. Our last practice problem will be sodium. Same steps as we used as before. The atomic number will give us the number of protons and electrons, which is 11. The neutrons is the atomic mass, which is 23, minus the atomic number, which is 11, which is going to give us 12 neutrons. Sodium has 11 protons, 11 electrons, and 12 neutrons. Isotopes are atoms of the same element that differ in the number of neutrons that they have. If we take a look at hydrogen, and with isotopes we just want to focus on the number of neutrons. The atomic mass, which is 1, and the atomic number, which is 1, will give you the number of neutrons. 1 minus 1 equals 0. So in a normal atom of hydrogen, there are 0 neutrons. In deuterium, which is the isotope of hydrogen, its atomic mass is 2. So 2 minus 1 will give us the new amount of neutrons of deuterium, which is 1. So an isotope is the same atom, has the same number of protons and electrons. The only difference is the number of neutrons change, which is going to also give it a larger atomic mass number. So the difference between deuterium and hydrogen is the atomic mass goes up by 1, which makes the neutrons go up by 1. Here's just a quick cartoon of something I saw from The Simpsons making a play off of Who Wants to Be a Millionaire. Hopefully we can get the answer here, which is C, bonbon. Today's objectives were to understand the components of an atom. These components are called subatomic particles, and they include protons, electrons, and neutrons. The second thing that we needed to learn today was to understand how to figure out the number of protons, electrons, and neutrons that are in an atom. The protons and electrons are the atomic number, and the neutrons is by taking the atomic mass and subtracting the atomic number from it. The third objective was to differentiate between an isotope and a regular element using the periodic table. Remember that an isotope has the same number of protons and electrons as the regular atom. However, the number of neutrons change because the atomic mass changes. If you have any questions, make sure that you bring all your questions to next class, and I'll see you there.